So, I have to admit something to you. I always had a soft spot for design patterns in software engineering, and that all started in university when one of my professors, Professor Bernd Brügge, shout out to you, gave the lecture Design Patterns in Software Engineering. And I kind of fell in love with the whole topic. I have the Design Patterns in Software Engineering book, the Gang of Four book, usually somewhere in my reach. And I still remember very fondly the day the professor talked about the dependency injection pattern, as he called it. And he brought a pastry and a long syringe filled with chocolate, and he dependency injected the chocolate into the pastry. And I feel like ever since that time, patterns have never really gone away from my life anymore. But I've really been meaning to refresh on them in the context of Kotlin. So when I saw that there is this wonderful book called Kotlin Design Patterns and Best Practices, I kind of wanted to share some of the things that are in this book. And who better to do that than the author, Alexey. Hi, Alexey.
Hello, thanks for inviting me.
All right, so today we are going to talk a little bit about design patterns and Kotlin.
Sure. First of all, about the problems of design patterns and what they are trying to solve. In the original book, the authors talk about the fact that they didn't invent those design patterns. A lot of developers, engineers treat it as something that was invented by the Gang of Four. In fact, they observed design patterns, they observed solutions to problems that they encountered in the code. And they kind of structured that knowledge. But design patterns were around long before that book.
That's also a very interesting point, is that oftentimes design patterns are less about saying, this is how you have to structure your code. It's more like, these are ways that other engineers who've kind of iterated on their designs multiple times, this is what they've come up with.
Yeah, I completely agree. It's design patterns allow us to build a common language. And I started my career as a Java engineer. I started it at SAP, so it was quite formalized. And people around me were talking about design patterns all the time. And then I moved to become a software architect in a company that was a Ruby shop. So the developers were doing Ruby, and those were great developers. They went like, no, we don't use patterns in Ruby. It's something like an enterprise Java thing. Like, we don't have them here. And like, it's still the same thing. They were just not calling it the usual way. So in the end, it's about building that common vocabulary, so we can say, hey, let's solve it. Let's have a factory there, and you don't need to add any more to that, I believe.
All right, and I think that's a wonderful segue, actually, because I think today we're going to start out and have a look at the factory design pattern, or maybe its descendants.
Yeah, so factory has kind of bad reputation. A lot of engineers think it's over-engineering. And there are a couple of interesting points we can discuss there. First, we say it ourselves, factory pattern. There is no such pattern in the book, actually. It's called a factory method. And a lot of people also confuse it with abstract factory, which is a different pattern, similar but different.
Okay, I'm itching to write some code because I think I remember things best when I got some code in front of me. So let's maybe start with that. Do you have a practice problem for me where I can see how factories or factory methods are going to be useful?
So let's imagine we have a game that you're building. In my book, I mentioned chess game. I think that's a good example. And as part of the functionality, you want to be able to load the state of the game. Either because you decided to turn off your laptop, or because you want to start from some well-known position in chess and see how it develops. So what you would have is a text file, usually some configuration file. Let's treat it as a text with positions of all the chess pieces. And the problem we are going to solve is how from that text file we are going to build the state of our game.
All right, sounds good. So I guess we could begin quite trivially, first of all, by just reading the string and having the text file.
Yep.
So I'm just going to quickly type out my what would this be called? A position, I guess.
It's called, I think, notation. What they actually call it.
By default, we don't even need to read it from a file. We can just have it in a string. So we'll have the notation right here, which is, you said, pawn at A3, for example.
Yep. And what that pattern deals with is with different types of objects that are somehow related. So what you will need is a list of those notations that are related but different. So let's assume those are all the different pieces that you may have. So let's make it a list of those strings, and let's add another piece, which is queen at, I don't know, C5.
Okay.
And now from that configuration, that's currently a text configuration, we want to create the actual objects. So one object will be pawn at with properties set to A3, and another will be an object of type queen, which is set to C5.
Okay, so we would probably just have like a pawn class, and those would then have a position, and then we would have a queen, for example, and that would also have a position. I guess we could already factor out a common base class here, but we'll keep it simple for now.
Yeah. And now, how would you translate the configuration that you have, the notations, into those classes? What will be your approach?
So actually, thinking about it, thinking about the method signature, which would probably be, I'll just call it generate pieces because naming is hard. And that will take a notation, which is a list of strings, and that would probably return a list of pieces. So at that point, I do need we could actually make it a sealed class piece, which just defines the position, and then we can have these implement piece, and hopefully just pass these through here. And we'll, whoops, a little too eager. Sorry, still a data class, my mistake. There we go. Okay, so I guess the most basic thing would be to go in and say, okay, so the first, as far as I can tell, I'm not an avid chess player, the first character determines the type of the chess piece.
Yep.
So we'll say piece type is my... Well, we'll go through each of the elements, so each piece in my notation. The piece type is this piece's first character, and then we can just say when the piece type, and then we'll go through and we'll say if that's a P, then we'll create a pawn which takes, I guess position is piece dropping the first.
Oh,
then
that's quite smart. I would take the substring, but drop is even nicer way to do that.
And then for Q, we would have queen at the position, and for the else branch, we would probably just error out and say unknown piece, and then we'd return this part.
We need to map it.
Good point. So instead of having this as a loop, I guess we would actually just map it. You're absolutely right. And then this is not a return statement. And then we'll just have a return here. Okay.
Yeah.
A long-winded way of saying an if statement or a when statement.
My rule is more than 3 ifs become and when. The question is what happens when you have exactly 3. I usually prefer to leave it if else, but yeah. And I think you demonstrated here the power of Kotlin and how expressive that language is. And yeah, that's basically you just implemented the factory method, which is great. And I didn't plan to write that book. I started with writing some articles on Medium about design patterns. And the reason is I became interested in Kotlin around 2016, where a lot of Java engineers were looking at Kotlin as well because it was very promising, easier than than Scala, more type-safe than Groovy, and more fun than Java. So it was a really good promise, and I believe Kotlin really kept on that. But what I noticed it was in Stack Overflow, it was on GitHub, it was articles on Medium, that people would just take the design patterns as they were in Java and just copy paste them to Kotlin and call it, that's how you do the design patterns in Kotlin. And Kotlin provides so much more in terms of the language, and it's much more concise and expressive on many levels. So first of all, we have that when block, which allows us to map between some parameters easily, so we don't need long ifs, and it also works better than Java switch. And then we have a return statement that we don't need return statements from Lambda, and we have the higher order functions on collections, so you just could map on an array without the need to convert it to stream and things like that. So I think that's just a fantastic example of how easy it is to use Kotlin for those kind of tasks. And what that pattern allows you is you don't need, now this logic is extracted from your code. Usually would have, that's the only code we wrote at the moment, but usually would have like a bunch of other classes that actually deal with the game, where you put your pieces, how you move them, or maybe some even logic that decides the best next move and things like that. And you want to extract out that boring logic of just loading your game. And that's what a lot of design patterns deal with, extracting that boring logic out of your code.
So we were talking about giving things names, and I just kind of on a whim called this one generate pieces and made it a top level function. Would you say that this is where my factory would belong, or would it maybe be more reasonable as a companion to piece, or as an extension function?
So I think it belongs just there because it's something static. It's something like I would call it maybe load game or something like that. But generate pieces is just a fine name as well, because like maybe the load game would actually read the text file, and that's what's great about Kotlin is that we have those top level functions. So unless we need an object, a class, we don't need to wrap everything in the class. And that's a lot of complaints about Java, is that everything needs to be a class, and we have those classes that aren't really classes, because load game, the function that you wrote, it's a pure function and doesn't have any state. So like why wrap it in a class in the first place? I think it's just in the right place.
Okay. So the only thing that I was kind of thinking about, and I'm just going to try to demonstrate this real quick, was that I could move this into a companion object, right? This function. Let me just bring this up here.
Mm-hmm.
And essentially this way, I kind of change my calling convention a little bit, right? Because now if I have my main function, ideally I wouldn't even now take a list of strings. I would now just take a string, and I would just return a single piece. There we go. And we'll return no longer a map. We'll just return our when statement again. This is our piece. There we go. Something like, I guess I would usually call this something like from notation.
Yep.
And then I could go in and I could say val notation, sorry, I shouldn't shadow it, val game state equals notation dot map, and then I would take each of these strings and I would say piece from notation it.
Yeah, and that's a wonderful example of static factory method. So what you did just now is, if before that factory method was a top level function, if we were in another language, it would sit in some factory class. Here you moved the creation inside the object itself. So you never do in your main function, you never do new. Well, there is no new in Kotlin, but still you never initiate any particular object.
Yep.
So you delegate the creation of the object to the object itself. And that's a really powerful design pattern. It's kind of evolution of a factory method to have those static factory methods. First of all, it allows you to create other pieces. So if we don't track the color of the piece, you could, for example, do that, and your main function wouldn't change at all because it all will be abstracted inside that piece static factory method.
Personally, I feel like I found myself writing these static factory methods most of the time because it feels very natural being able to also give a name to the way that you are constructing things. If you would just have multiple constructors, which of course with an inheritance hierarchy that's not that easy, but if you just had multiple constructors, you're kind of in this territory of overloads where you're like, well, what does this specific combination of parameters really mean? Whereas here it's clear, if I just read the line number 9 here and I say, well, this clearly creates a piece from notation. There's no question about, it's not that the ID of piece is now going to be set to PA3 or something like that.
Yeah, that's exactly the point, that you have a better naming for your constructors that way. And we have it all over JVM at the moment, so you can create longs, strings, and so on, because they have those nice factory methods now.
Big integer as a value of.
Yeah, that's an excellent example of that as well.
All right, so in this example, we are... This is essentially the same thing that we've built here. They just call it value of instead of from value, I guess. But okay, that's very elegant.
And it also allows you to do things that you sometimes don't want to do in constructors. So there are discussions where whether a constructor should throw an exception or not.
Mm-hmm.
But
which we are doing, by the way. Mm-hmm.
Yeah, but if we extract that to a method, to a function, then you should expect that the function will be able to throw an exception.
Sure.
So that's one other useful thing. And some of those static factory methods would also cache values.
That would have been my next question, actually. Because it seems kind of natural. You're like, well, if I'm creating a lot of objects that are kind of the same, why wouldn't I just return the same instance? Like, there's nothing keeping me from just giving this companion object like a cache, which would just be a map of a string to a piece.
Mm-hmm.
Like, this is something that you could absolutely do.
Exactly.
Map off, but yeah.
And that's what, again, something you probably wouldn't do in a constructor, even if technically it's possible. But when we are discussing a method, it's quite natural to have something like that in a method. So yeah, that's a fantastic example.
Yeah, when you iterate on your code and you kind of arrive at this, it's very interesting. So I've also seen people put this not in a companion object but in an extension function. Do you know whether there's a reason for it and when I should choose one over the other?
So I believe we'll discuss extension functions in more detail in other design patterns. But in my opinion, it's a lot of question whether you can modify the code or not. Sometimes you are not able to modify the code and you just want a helper method to create those objects, and then you would put it in an extension function. Mm-hmm. But it doesn't allow you to store any state, and it doesn't allow you to do some of the nice optimizations that we discussed previously.
Not being able to store state seems like one of the big ones here. But it does seem reasonable that you would have, for example, representation in a different format, and then you would also just do a from something else.
In the earlier days of Kotlin, nowadays the JSON libraries matured quite a lot, I believe, and it's easier to use them. But when we just started and all the JSON libraries were just Java libraries that we brought into Kotlin projects, I would see that quite a lot, that people would do an extension function on even a string that would be called like something to JSON or to my object. And inside that extension function, you would map it. Don't see it that much nowadays because like there is Kotlin serialization, which kind of solves all those problems, and also all the other projects, libraries like JSON, JSON, they all added support for Kotlin as well. But yeah, previously you could see that.
Okay, but this brings a question up for me now. Because I think if I just understood you correctly, you said they were extending string, for example, with a to JSON?
Yeah, so you would have something like, yes, it would accept, and then you would have something like even to JSON.
But now I'm curious, because there's two ways to approach this, right? Like, we could either have something that will be something like JSON.fromString, or we could have string.toJSON. I guess they're both doing the same thing, but like, how do you decide where does your function go?
So in this case, I would say that it's probably string is a very commonly used object. So I wouldn't overload it too much, because then we will end up with auto-completion that never loads and things like that. So in this case, I would say like, what's more specific? Is it JSON or is it string? And like JSON is much more specific, so I would say it's this method should belong to JSON.
Okay. And there's one more question, because I'm just like a parrot. I pick things up and then I kind of spit them back out when it comes to code.
We all are Chinese rooms.
That's right. It's not necessarily a bad thing, but I just named this like from notation because that felt like it would be the natural thing. But what actually is the naming convention for factory patterns or for factory methods? Because beforehand, we called this something like generate game, or we called it maybe load game, and now we call it from notation.
I'm not familiar with anything specific. So JVM itself uses value of quite often, which like I'm not sure if it's a deliberate choice or not. I think like the from something is a good standard.
So, Alexey, can you summarize for us once again, kind of to round everything out, what kind of problem we're solving with the factory pattern, while people, I guess, can intensely look at the code that we've written here?
Yes. So what we are trying to solve is to create multiple related objects from usually some kind of configuration. So in this case, all the chess pieces are pieces, so they are all related, but they are also different because like pawn doesn't move like a queen. And we encapsulate that logic in one single place, so we wouldn't have ifs spread across our code saying whether I want to create a queen or a pawn and things like that.
We are essentially centralizing the logic on how we pick a specific object to this factory method.
And we also abstract on what we return. So we don't say, like we cannot say that way that we return a queen or a pawn or something else or a bishop. We just say we return a piece, and from now on, your entire application will work with that abstraction of a piece, of a chess piece.
So if you are out there and you find yourself writing a function that starts with from, you might already be using the factory pattern. If you think this was useful, there's a lot more patterns in Alexey's book, and hopefully we can bring Alexey on for another episode where we'll talk about one or two more patterns in the future.
Absolutely, would love that.
Hope you enjoyed this episode. See you in the next one. Take care. It's so interesting where I sometimes sit down and I look at a piece of code that I've written, which is garbage because I wrote it at like 5 a.m. after like 6 coffees, and I like iterate on it and I iterate on it and I iterate on it, and then I look at like any of the design patterns books and I'm like, well, I've just like reinvented something that exists from first principles again. Which on the one hand, sometimes it feels a little bit like a waste of time, but on the other hand, I feel like that's when you kind of, when it like clicks, you're like, oh, I have understood like the steps of how this even came to be and why I would even need it. I'm not using it because a book said I have to use it.
Exactly, and there is also the opposite of that. You won't see it that much nowadays, but like 10, 15 years ago, you would see people implementing patterns just for the sake of implementing patterns without like actually solving any problem. Like factories that would create just one type of object because like their domain would have just one type of object and so on. Yeah, it's you don't see it that much nowadays, I believe, but still.